Okay, now let's look at the integration of sine squared and cos squared, which is our case 1 of integration using trigonometric substitution. All right, this trigonometric substitutions make work easier for us. Now, whenever you see yourself having a sine squared x or a cos squared x, okay, whatever the x may be, if there's sine squared or cos squared, then you are going to make use of the relationship that says that the double angle formula of cos 2x. This double angle formula of cos 2x, we can express it in two ways, right? The first way is that cos 2x, you can say cos 2x is equal to 1 minus 2 sine squared x. And then you can also say cos 2x is equal to 2 cos squared x minus 1. It's not hard, is it? When it meets another cos, if you're taking from cos 2x to a cos squared x, the cos squared x is positive. If you're taking to sine, it becomes negative because you know that cos to sine is negative, right? Now, what we are saying is that you must be able to be familiar with the double angle. Of course, you know the double angles, we use them not necessarily when we just have 2, but when you have multiples of 2. To say 2x, 4x, 8x, 10x, okay, or 2t or whatever, right? That's the idea we use when we are having anything to do with either a sine squared x or a cos squared x. So before we see the replacement we're going to do, let's first make sine squared x the subject and cos squared x the subject. All right. I'll have cos 2x equal to 1 minus 2 sine squared x. Never forget this 2 that comes with them, okay? 2 sine squared x, 2 cos squared x, all right? Now, if I want to make sine squared x the subject, I'll take it to the left-hand side, and then I'll take cos 2x to the right-hand side. So this negative 2 sine squared x becomes a positive 2 sine squared x because it has changed the side of the equal sign, is equal to 1 remains as it is. Then cos 2x now becomes negative because it has changed the side, 1 minus cos 2x. Then what I'm going to do is divide both sides by 2. Divide both sides by 2. This 2 and this 2 cancel. I now have sine squared x. It's equal to, dividing by 2 is the same as multiplying by half, so it will be half of 1 minus cos 2x. Wow, it's a beautiful, beautiful thing. Sine squared x is equal to 1 minus half of 1 minus cos 2x. You don't have to remember this form. If you remember the double angle formulae, then you can make it subject real fast and find out what it means. All right? And we can also do the same for cos. Maybe let me write in a different crayon. Cos 2x will be equal to 2 cos squared x minus 1. I mean, you can remember this. Well, let's make cos squared x the subject. In here, we just have to take this negative 1 to the other side. It becomes cos 2x plus 1 is equal to 2 cos squared x. We divide both sides by 2. And dividing by 2 is the same as multiplying by half. So half of cos 2x plus 1 is equal to this 2 and this 2 cancel. Is equal to cos squared x. And this is an important relationship that you don't have to cram. But just remember the double angle formulae and then you can make these guys subject. Once you're like this, if you now get an integral, for example, they say, what is the integral of sine squared, let me say, 5x with respect to x? Well, you know that anything that has a sine squared, you replace it with half 1 minus cos 2x. You would have made the subject, right? So this will be equal to the integral of half multiplying 1 minus cos 2x, all with respect to x. And any constants that multiply, we can take them outside as long as they are multiplying, or dividing. So here, it's multiplying, I take it outside, half is now outside, and then now I have the integral, which is my beautiful s, the scale is, of what? Of 1 minus cos 2x, and all this is dx with respect to x. Now, how beautiful this gets, because what I know is that anything that has an addition or subtraction sign separating them is very easy to integrate. Okay, so if I now integrate, it's equal to half multiplies, half is multiplying. The integral of 1 with respect to x is just x, minus the integral of cos 2x, right, is negative 2, rather, negative 2 sine 2x, okay? Because cos 2x is actually a compound angle. So when we differentiate this, it's going to be derivative of cos 2x is equal to negative 2 sine 2x, okay? It's negative 2 sine. So that's what I had, negative, this negative of negative 2 sine 2x, all right? So now this becomes equal to half x. Remember to add the constant of integration. Never forget it, as long as it's an indefinite integral. This becomes x plus 2 sine 2x. But if you notice something, though, that we had made a big mistake, is that this was not an x, but it was a 5x. If it was an x, then we would have it exactly like this. So it's a 5x. In other words, that 2x we had, we multiplied by 5. Okay, that 2x, only in this, in your trig identity. So if I were to change, I would have half of x plus 2 sine 10x plus c.